We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live, streaming in real time around the globe of them watching all of this. Take a look at this.
Oh,
everybody.
Oh, nice.
Yes, look at that bad boy.
This is a raw image, so this is not even like, this is just directly from the telescope right now.
You're looking at a piece of what would have become a planet in another star system. This is a building block from somebody else's home.
There's still so much we don't know, and with the sun's glare taking over, our window to see this interstellar visitor from Earth is closing fast. Meanwhile, Mars is about to get a front row seat coming up on the cosmic calendar October 3rd. That is when 3I Atlas swings by the big red planet and NASA's Mars Reconnaissance Orbiter. That could give us our best look yet.
Using the Gemini multi-object spectrograph, astronomers captured Comet Atlas in ultraviolet, blue, red, and near-infrared light. What they saw left no doubt: a long, fragile anti-solar tail stretching more than 50,000 kilometers into space. In just a few weeks, the coma had expanded to nearly 19,000 kilometers. Atlas had transformed from a dim speck into a blazing comet, complete with a streaming tail, the unmistakable mark of a body pushed by the sun's radiation. Fresh images from Gemini South revealed dust and ice being blown away from the nucleus as it heated up, forming that glowing, expanding tail. These are textbook comet features, shattering the wild theories that Atlas could be some kind of alien probe or artificial object. So why does the tail stand out so clearly now? Two main reasons. First, physics. As sunlight intensifies, the comet's frozen gases vaporize faster, dragging dust with them and building a brighter, longer tail. Second, geometry. Back in July, the tail was aimed mostly away from us, making it appear shorter. Now, as our view shifts, we see the full sweep of it. And for those hoping Atlas was something mysterious, this pretty much ends that fantasy. Seeing both a tail and an expanding coma is exactly what we expect from an icy body heating up near the sun. The good news for science is that now, with the tail visible, astronomers can study Comet Atlas in far greater detail. But there's a small timing issue. The tail will keep growing as Atlas approaches perihelion on October 29th. Yet Earth will be on the far side of the sun, meaning we'll likely miss its brightest peak because of glare. The best viewing window should return in December, when Atlas is around 170 million miles away and the geometry improves again. Its glowing tail isn't just beautiful, it confirms Atlas's true cometary nature and gives scientists a rare chance to explore its alien chemistry. With the dust tail now visible and the carbon dioxide coma mapped, both the James Webb Space Telescope and ground observatories are perfectly placed to study how an interstellar comet activates as it races through the inner solar system. Fresh images taken during last week's total lunar eclipse revealed something extraordinary: a faint green tint spreading across the comet's coma. Astronomers believe this glow comes from sunlight triggering reactions in the comet's gases as it draws closer to the sun. On September 7th, astrophotographers Michael Yeager and Gerald Raymond captured the effect during the blood moon, revealing an eerie emerald halo around the icy wanderer. The strange green glow may come from volatile materials buried deep inside the comet's core, now released as sunlight grows stronger. Still, it's too early to be certain. No other observatories have confirmed the same color shift yet, but comets showing a green halo aren't new. Just last year, the striking Devil Comet 12P/Pons-Brooks turned bright green on its way toward the sun. And recently, astronomers spotted another, newcomer Swan 25F, showing that same emerald hue. The usual culprit is diatomic carbon, two carbon atoms bonded together that shine green when hit by sunlight. This chemical often forms in the coma, the hazy cloud of gas and dust surrounding a comet's nucleus. Interestingly, spectroscopic readings of 3I Atlas haven't shown any clear signs of it yet. Scientists think the compound may be trapped beneath layers of ice, now only starting to vaporize, or perhaps the glow comes from a mix of unknown gases creating a similar effect. Meanwhile, NASA's fierce mission detected a vast cloud of carbon dioxide stretching nearly 350,000 kilometers around Atlas. Then, on August 6th, the James Webb Space Telescope turned its infrared spectrograph toward the comet and found something shocking: carbon dioxide dominating at a ratio of nearly 8 parts CO2 to 1 part water, one of the highest ever recorded in any comet. The James Webb Telescope also detected carbon monoxide, OCS, and dust, but only faint traces of water, the key ingredient in most comets. Later, Hubble refined those findings. While it can't see the nucleus directly, hidden behind the bright coma, it can estimate its size from brightness. The results were shocking. Atlas's core is tiny, no larger than 2.8 kilometers in radius, and possibly as small as 160 meters. That means its diameter could be anywhere between 0.3 and 5.6 kilometers, smaller than most comets in our solar system, yet it's releasing gas like a giant. Imagine a snowball the size of a small-town venting material at the rate of a mountain-sized comet. Completely unexpected. Then came more intrigue. Using the Very Large Telescope, astronomers found nickel gas in the coma, but no iron. Normally, nickel and iron appear together, forged side by side in the violent heart of supernovae. Their separation here is strange and could hint at a chemical history born in a very different kind of star system, maybe even an entirely alien environment. While it's unlikely to be technological in origin, Atlas stands out as one of the strangest comets ever observed. Small, but wildly active, poor in water, yet rich in carbon dioxide, and marked by an unusual chemical fingerprint. To make things even weirder, its orbit slices suspiciously close to the plane of our planets, as if it didn't come from deep interstellar space at all, but from somewhere uncomfortably familiar. Comet 3, I-Atlas, is diving into the inner solar system on a steep retrograde orbit, moving opposite the planets. Astronomers have already marked several key moments as it speeds through our cosmic neighborhood. October 3rd, 2025, Mars flyby. Just after sunrise over Valles Marineris, Atlas will sweep past Mars at only 18 million miles. Orbiters like NASA's MAVEN and China's Tianwen-1 are expected to capture its dusty coma, glowing faint pink in the Martian dawn. October 29th, perihelion. 4 weeks later, Atlas will swing behind the Sun, coming as close as 1.36 astronomical units, about 130 million miles from the solar surface. Its velocity will spike to nearly 152,000 miles per hour. From Earth, the comet will vanish into solar glare, but probes near Mars and L1 will keep watching as new jets burst from its sunlit crust. December 19th, 2025. Earth distance check. Atlas will pass 170 million miles from Earth, too far for the naked eye, but close enough for the James Webb and Rubin observatories to study its isotopes. March 16th, 2026. Jupiter Pass. Finally, the comet will cruise past Jupiter just 33 million miles above the gas giant's clouds, its last close encounter before vanishing back into deep space. If NASA approves a late trajectory tweak, the Juno spacecraft could intercept part of Comet 3 I-Atlas's dust stream, giving humanity its first close-up taste of material born beyond our sun. After its October perihelion, Atlas will swing back into interstellar space, never to return, leaving behind a mountain of data and plenty of mysteries. Some astronomers even suspect Atlas is older than the solar system itself, a frozen relic from the Milky Way's thick disk, wandering for billions of years before drifting into our neighborhood. As it nears perihelion on October 29th to 30th, 2025, the comet will pass safely at 1.36 astronomical units from the Sun, close enough for constant monitoring. During this encounter, Atlas's activity will surge, its gases venting faster, its glowing tail stretching farther under the solar wind. For scientists, it's a rare moment when a comet under stress reveals its true nature. As Atlas flares under the sun's heat, it might finally give up its long-held secrets, what it's made of, where it formed, and how it survived so long alone in space. In less than a decade, humanity has witnessed 3 interstellar visitors, each one unique, each one rewriting our understanding of the universe. And now, as Atlas blazes through our skies one final time, we're not just seeing a speck of light, but the passing memory of a distant world, fading forever into the dark. What do you think? Share your thoughts in the comments. I'd love to hear your take on Comet Atlas and what it might reveal about our universe. If you enjoyed this breakdown and want to stay updated on every new discovery beyond our solar system, make sure to like, subscribe, and turn on notifications. Your support helps keep these deep space explorations coming. Thanks for watching, and as always, keep looking up.